Well, Algebra 2, this is a refresher video on factoring a trinomial when our leading coefficient is 1. So we're going to go over a couple examples, and hopefully this will refresh your memory on it, and you'll be able to complete that remediation worksheet that goes along with this section and get an exam retake. So let's look at our first example. We'll just go through two. So we're given the equation a squared plus 5a equals -6. So the first thing we want to do is we want to make sure that our trinomial is written in standard form. So what we want is ax squared plus bx plus c equals 0. That's what standard form is. Okay, so you'll notice, and it doesn't matter if we have a plus or a minus in between these, but what we're looking for is all of our terms to be on the left side and our equation to be set equal to 0. And we're also looking for this to be written in degree going from largest to smallest. So here's squared, this is an exponent of 1, and then there's no x term over here. So that's that we need to rewrite this equation to look like that standard form right there. So we have our squared term in front, that's great, and then we have this next term with our degree of 1 term here, but our constant is on the other side of the equal sign, so we need to bring that over. So I'm going to add 6 to each side. And when I rewrite this in standard form, I get a squared plus 5a plus 6 equals 0, which is exactly what we want. So now we get, if you remember those diamond problems we did back when we were learning this, what we were looking for is we were looking for two numbers that we multiplied together equaled this term c, all right, and then we wanted two numbers that we added together equaled 5. So we had to take all the factors of 6. If we broke that down, we could multiply 1 and 6, or -1 and -6. Those when multiplied together would give us 6. Our only other factor pair was 2 and 3, or -2 and -3. So when we look at those four factor pairs, the only pair that when we add together equals a +5 is right here, +2 and +3. And the reason why we want that is when we set up our factor with the parentheses, whatever numbers here are going to be what are the numbers rounding off the parentheses here. So we're going to have +2 and +3. What goes in this spot? Whatever we were squaring here, and we were squaring a. So our variable goes there. So what we have is a plus 2 times a plus 3. That is our factored form of our trinomial here. Now this is all equal to 0. We've only factored it now. We haven't solved it. Now we have to come up with the values of a that will make this 0. Well, how do you get anything by 0? You multiply whatever the other thing is by 0. So we're going to set a plus 2 equal to 0, and we're going to set a plus 3 equal to 0. We subtract the 2 from each side on this one, we get a equals -2, and if we subtract it over here, you get a equals -3. So that's our answer here. If we were to plug that in here, this set of parentheses would become 0. So whatever was over here multiplied by 0, that would equal 0. Or if we were to plug in -3 over here for a, we'd get -3 plus 2. That's -1, but it's -1 times 0. So that gives us 0. So anything that makes our factored form equal to 0, those are our solutions. So in this case, a equals -2 or a equals -3. Those are our answers for this first example. Let's go through one more. I have p squared minus 6p equals 27. Well, remember, we want to get that written in that form, ax squared plus bx plus c equals 0. Basically, we have to set this equal to 0. In order to do that, I'm going to subtract 27 from each side, and I'll get p squared minus 6p minus 27 equals 0. So remember that diamond problem. We want to get two numbers that when multiplied together equal -27, and when added together give us -6. So we have to start breaking down the factors, the factor pairs of -27. Well, obviously -1 and 27, if we multiply those together, or its counterpart, a +1 and -27. Okay, well those when added together don't equal -6, so let's just keep going. Does 2 go into 27? No. Does 3 go into 27? Sure. We get -3 and 9, or a +3 and -9. Does, let's see, 4 go? No. 5? No. 6? No. 7? No. 8, and we're back up to 9. So here are our factors of 27. Let's add these together, see if any of them equal -6. It would be that one right there. 3, a +3, and a -9. Those are our numbers that we're going to use in our factored form of this trinomial. So let's set up our parentheses. We're going to begin with our variable. So we'll have p at the beginning. And how do we finish off each parentheses? We plug in these numbers we just figured out, +3 and -9. That is our factored form of the equation. So now we need to set each one of these parentheses equal to 0. So p plus 3 equals 0, or p equals -3. Over here we have p minus 9 equals 0, or p equals a +9. So there are our answers for this particular one. P equals 9, or p equals -3. So hopefully these two examples remind you how to factor a trinomial when that leading coefficient is 1. There will be a second video that goes along with this. What do we do when the leading coefficient is greater than 1? So that'll be the second video to go along with this unit and the remediation worksheet that goes along with Unit 5, Section 2.